Alright, this is the Festo Station that we'll be using in lab number 6 and lab number 7. And to begin with, I'm going to look at the 4 analog sensors that measure various signals like temperature, pressure, level, flow. And to start with, this here is the RTD temperature sensor. It has a rod that goes into the tank to measure the tank temperature. And it's an RTD, so there are 3 wires attached to it. It measures a range of 0 to 100 degrees Celsius, and its resistance changes by 100 to 138.5 ohms in that temperature range. So that's for measuring temperature. It's called B104. Moving over to here, this is the flow sensor. It has water flowing through these pipes, comes through the pump motor into this tubing here, but measures a flow rate in the range of 0 to 9 liters per minute, and coming out of this cable is 0 to 1200 hertz. Okay, so it's proportional to the flow rate that you have here. Eventually I'll talk about the converter modules that are in the back, but again, 0 to 9 liters of flow coming in, 0 to 1200 pulses per second coming out. So that's the flow sensor. Moving on to the pressure sensor up here, B103. This pressure sensor measures the pressure in this tubing, and its input is 0 to 400 millibar, so 0 to 400 millibar, and an output of 0 to 10 volts on this wire. So there's no converter required for this. This is about the most simple. And 0 to 400 millibar is about 0 to 5.8 psi. So that's the second analog sensor. Over to the that was the third. Over to the fourth one right here. This is the ultrasound level sensor. It has a range of 0 to 300 millimeters in that tank, so it's able to tell the level by detecting the surface. And it uses ultrasound, so a beam hits that surface of the water, reflects back to the sensor, and is able to measure that. Now the output of this level sensor is 4 to 20 milliamps. So it requires a converter, which there is one in the back, which we'll look at in just a second. But the output of this is 4 to 20 milliamps for a range of 0 to 300 millimeters. Now, the next thing I'm going to look at is not one of the analog sensors, but I want to point it out. It's press Start, All Programs, go to Festo Didactic, Fluid Lab, and the EduKit. Click on that. It opens up this screen. The first thing that you have to do is to change the language. So Sprach is language in German. You switch that to, should come up in a second here. Change it to English. And I think this word is OK. And now it's in English. Then click on Setup. Okay, and what this will show you is various analog inputs like the level of the tank, the flow rate, the pressure of the pressure sensor, and the temperature in degrees Celsius. Then I can also control things like the ball valve, which to do that you have to turn on the air supply, which is down here. So you have to turn on this lever first, and you want to get about 2 to 2.5 bar, and you can see that it's set to that right now. So when that is set, you can hear in the background that a valve can be opened and closed. I can turn on a pump. You can hear in the background that that pump is going on, and this thing is showing you the values of things like level, flow, pressure, and temperature. Now over on the left hand side, these are the actual voltages that are coming from the sensors. So for example, from the level sensor I'm getting 5.6 volts, almost no voltage from the flow sensor, and so on. So what I'll do is set things up on the Festo Station to show you how these things actually work. Okay, so I'm just going to show you the operation of the flow sensor when we actually have some flow going into the tank. So coming back to the screen, I'm going to enable the pump motor. So you can see I've just done that, and if you look at the screen, you'll see right here that I have some flow now. It's measuring this in liters per minute, but over here is the voltage where my mouse is pointing to that shows you the voltage that I'm getting from my sensor. And recall that 0 to 9 liters of flow gives you 0 to 1200 hertz, But then you have a converter that converts the 0 to 1000 hertz to 0 to 10 volts. So I'm actually getting 433 hertz. From that you can figure out the liters per minute. So back to the workstation, you can see that there's flow in the top tank. It's actually going from here through the pump motor, through the flow sensor, into this pipe, and eventually into the top of the tank. So if I stop that motor, you'll see that the flow drops down to 0. I wanted to show you one other thing. There's a bit number 2, which controls whether the pump operates with an analog signal. So if I turn this on, now I can control the speed of the pump with an analog signal. So if I'm over here, I'm getting a lot higher speed, and you can see the flow rate changes as well. I'm getting 4.3 volts. And it's proportional, so I slow it down. Okay, so I just wanted to show you that, and it's this switch that changes mode. So when it's up, it's analog. When it's down, I can control it digitally. Alright, that's it. Of the proportional valve. And so you can see right now it doesn't seem to be any levels changing because it's pumping, but it's not going anywhere. So I want to direct it a certain way, and it's from the bottom of this lower tank through the pump into here through the proportional valve. So you'll notice this one's shut off right now. So when this proportional valve's enable, it should go from here to here. I've shut off this valve. This valve's open. Should go through this tubing, through here, and into the top of this tank. The other thing to note, while it's running, this clear tube is going to show you the state of level in this tank, because we can't see it, but just like those older coffee machines that had a clear tubing on it, it'll actually show you the level of the inside of the tank with a clear tube on the outside of the tank. So eventually this is going to rise up as I open up that valve and allow flow into this lower tank. So back over to the screen, one of the things I have to do is to enable the proportional valve, and it's done with bit 4. So it's now enabled, and then if I move this slider, it's going to open the valve, and I'm going to open it 100%. So back to the station. Now have a look at the level in that plastic tubing. It's starting to go up. It's going to take a little bit of time because it's filling the tubing, the tank, and now we're probably filled in the tank, so it's going to be a little quicker. It's going to come into this point here and start to fill the tank, and you can see that happening. Okay, so it's actually going right now through this proportional valve because I have it enabled. Now back over to the screen, if I move this slider, okay, I'm going to move this slider back and forth, but I want you to see the station. And so right now the slider's all the way to the right. It's filling the tank with a lot of flow, but I'm going to move it halfway, and you should see the flow starting to reduce until it's cut off completely. And I'm doing that through the proportional valve. So here's the valve at 10 volts, fully open, at about 5 volts, halfway, 2.5. So it's only about a quarter open now, and then fully closed. So moving that slider back and forth, I'm controlling how much liquid is flowing through this tube, proportionally. Okay? So that's the proportional valve. Alright, the next thing I'm going to talk about is the process ball valve, which is this whole unit here. It's an electro-pneumatic device, which means it's controlled with an electrical signal and a pneumatic air supply. The electric signal is to this solenoid valve, and there's a 24 volt signal. When I energize it, turns on this valve, allows air to flow into here, and the air is coming from tubing down to here. That's why you have to have a air supply. And down here is a regulator. That regulator needs to be set to about 2 bar. Make sure this valve is open. If you need to control the pressure, it's with this dial. And that connects over to here, under the bench, and to an air supply down here. Okay, back over to here. So right now, I can tell that this valve is closed because this little yellow indicator is perpendicular to the tubing, so it's not allowing any flow through here. And up here is the ball valve, but this thing's actually going to turn 90 degrees clockwise, 90 degrees counterclockwise to control this and the feedback switches. So let me just try that. So I'm going to get it to open. Okay, and you saw that yellow indicator change. And it went back. And now we'll have a view looking down from the top. Okay, so watch the two switches. Right now, it's the bottom switch that's closed. But if I energize it, okay, you see the top switch closing and water's flowing into the tank. Okay. Okay. Okay, the next two things I want to point out here are the electric heater, which is down over here. The electric heater is used to heat the water in this tank, so there's an element going down into here. It's a 1,000 watt element, plugs in up there where it says heater, and it's going to be used to heat up the water. And I energize it with a bit 1 switch, okay, which is up on the screen, so it turns it off, turns it on, back to the station. And you can see down here a light comes on when the heater's on. You actually start seeing some bubbles rising in the tank. Takes a little bit of time, but you'll actually see a film starting to move upwards as you're heating the water. I can see it visually. I don't know if the camera can pick that up, but it's there. Now back to the heater. So this heater's 1,000 watts. While it's heating, it can heat 1 liter of water by 1 degree Celsius every 4.2 seconds. So it has that capability. So again, that's every 4.2 seconds, it can heat 1 liter of water by 1 degree Celsius. So that's the electric heater. I'll turn it off at this point. There are 3 floats on the Festo system. S117 doesn't actually connect to any of the electrical signals. It's a safety float so that when the level in this tank goes below that float, it actually cuts off the heater. Because if there's no water in here, you don't want to be running that heater. So it doesn't go back to the Festo system or the software on the screen. When it drops down below, it turns this heater off. The next float is up here. It's at the top of the tank. It uses a magnet and a reed switch that when that level reaches the top of the tank, the float inside there will float upwards and either turn on or off the internal reed switch. And it's really just a way to detect that you've hit the top of that tank. Over on the upper tank, there's a float on the side. Right now it's buoyant or floating. So the plastic piece inside the tank is actually lighter or less dense than the water in the tank. So when it rises up, it closes a reed switch and then sends a signal to the computer, and that one's called S112. The one on the top of the tank is S111. Okay, so those are the 2 floats, or sorry, 3 floats. 2 of them are electrical signals. S117 is a safety for the heater. Okay. All right, there are 3 converters in this system here that convert signals from 3 of the sensors to outputs between 0 and 10 volts. The first one on the left here, you can see that it indicates input and an output, which is in the range of 4 to 20 milliamps to an output of 0 to 10 volts. That's actually coming from this sensor over here, which is the level sensor. So it measures 0 to 300, produces an output of 4 to 20 milliamps, and then an output of 0 to 10 volts that we feed into our PLC or the Festo system. The next one over comes from the flow sensor. You can actually see a photo diode and a photo transistor here picking up the square waves from the flow sensor, converting them to digital signals, or sorry, an analog signal. The input is 0 to 1000 hertz, the output is 0 to 10 volts. The third converter here is, you can see down here a picture of 3 wires. The slashed line indicates that it's actually measuring a change in resistance from 100 to 138.5 ohms, converting it to 0 to 10 volts. Okay, and there's a couple of others in here. This is the motor controller. Over here are two other ones that measure, or sorry, not measure, but they're relays for the solenoid valve and for the motor controller. So those are two relays that will come on and off. Over here is a box that we're going to use to monitor the inputs, the outputs, the analog signals, and to switch between analog channels, you press this red button and it'll show you the voltage from 0 to 10 for the 4 analog inputs, the level, the flow, the pressure, the temperature, and the 2 analog outputs are the proportional valve and the motor speed. Okay. The other thing, this one connects using an RS-232. The other one connected with USB. To hook up the RS-232, you actually have to come over here, and underneath the benches you can see that there's a RS-232 connector cable. That's where that will plug into. Okay.